Assalamualaikum and good day. So today we will look at topic 5.4, volume. If a region in the plane is revolved about the given line, the resulting solid of revolution and the line is called the axis of revolution. When calculating the volume of a solid generated by revolving a region bounded by a given function about an axis, we follow the following steps. First, sketch the area and determine the axis of revolution. This determines the variable of integration. Second, sketch the cross-section by using either disc, washer, or shell and determine the appropriate formula. Third, determine the boundaries of the solid. Fourth, set up the definite integral and integrate in order to get the total of volume. Let's start by looking at solids of revolution. To calculate the volumes by using this method. The main concept as explained below. A solid of revolution is a solid in three-dimensional figure created by rotating a subregion of the xy plane around a straight line, usually the x-axis or the y-axis. Okay, depends. Either we revolve about the x or we revolve about the y-axis. Assuming there is a single function y equal to fx, which defines the upper boundary of the region, and the lower boundary of the region is the x-axis, and the region is bounded on the left and right by the lines x equal to a and x equal to b. This defines the limit of integration given by lower limit a and upper limit b. The volume of the solid can be found using this method. For example, let's say we have the function fx equal to x. Then we will have this straight line here. So means that this straight line is our upper boundary region. And this straight line is bounded until the x-axis here. Okay, for example, from 0 to 10, so the x-axis here is our below boundary region. Then we can find the volume of this region, okay, which represent a solid. If we rotate this about the x-axis here, so by rotating this about the x-axis, it will give you a cone, okay, something like cone here. So we can calculate the volume of this cone by using this method formula. Alright, we will look later. Okay, since we know that by calculating volume, actually we talk about the radius. So the given fx actually represent the radius of our volume in the formula when we calculate the volume of revolution. Alright. So we will have two formulas. Okay. Volume by this perpendicular to the x-axis. Suppose R is the region bounded by y equal to fx, the x-axis, where x is from A to B, then the volume of the solid revolution that is generated by revolving the region R about the x-axis is given by this formula. V represent the volume equal to integrate from A to B pi times with fx squared dx. Alright, so this is another example. Let's say you have the straight line y equal to 3x. Then you want to find the region, and then you want to calculate the volume of this solid if we revolve about the x-axis from 0 to 1. Okay, so by revolving this region here, it will give you a cone. Then we can calculate the volume of this cone defined from 0 to 1 by using this formula. And we have the other formula if we want to calculate volume by this perpendicular to the y-axis. Suppose R is the region bounded by x equal to fy, then y-axis defined from the lower limit c to the upper limit d. Then the volume of the solid of revolution that is generated by revolving the region R about the y-axis is calculating by using this formula for the case of volume by this method. Alright, then if we revolve about the y-axis, we will use this formula. Okay, next we will look at example. Example 1, find the volume of the solid generated by revolving the region between the y-axis and the curve y equal to 3 over x when this is not the example. Example 1, find the volume that is generated by revolving the portion of the curve y equal to 2 over 3x between x 0 to 3 about the x-axis. So we will rotate about the x-axis. So let's sketch first, okay, in order to find where is the region to calculate the volume of our solid. So y equal to 2 over 3x so if x equal to 3, then I have y equal to 2. So at this point, so this is just a straight line. So I have this. Alright. So this is y equal to 2 over 3x. Then x is defined from 0 to 3. So we calculate until here. Alright. So this will be the region. Okay. This will be the region here. And in this volume, we talk also about the radius. Actually, the radius, if this is the center, so the radius is actually given by the function fx. Okay, fx is our radius actually. If we talk about what is the radius here from this point, okay, also we can calculate the height by looking at this fx. So here also we give the radius at this point. Okay, alright. Then we revolve about the x-axis. Okay, we revolve about the x-axis. Means that we will have it will give us the solid. Okay, the solid of revolution. Then if we can see here, we can have something like cone here. Okay, we can have something like cone here. Alright. Okay, so how to calculate the volume? So we will use this formula in order to calculate the volume given by the solid of revolution when we generated this solid about the x-axis here. So let's calculate by using the formula. So volume is equal to integrate from lower to upper limit 0 to 3 pi fx squared, so 2 over 3 square dx. Then I have 0 to 3 pi. So by expand this, sorry, I missed the x here. So by expand this, I should have 4 over 9 x squared dx. Okay, let's simplify. Bring all the constant outside. So I have 4 over 9 pi. Okay, then I integrate my x squared. I should have x cubed over 3 for the limit 0 to 3. So 3 multiplied with 9 outside, so I have 4 over 27 pi. Substitute the limit 3 power 3 minus 0. So 3 cubed is 27. 27 cancel with this 27, so I have V equal to 4 pi unit cube. So you can either multiply with pi, so leave it in 4 decimal place, or you can just keep in this form by keeping your pi here. So the total volume generated by this solid is 4 pi unit cube. Okay, so if I can share with you Maple, again, I love to share by using Maple. So Maple also can calculate the volume of revolution. So this is our curve, okay, 2 over 3x. Then rotate about the x-axis from 0 to 3. Then we will have this solid here. Then we can calculate the volume of this solid, okay, by using the formula. Alright, so same, but this in value. Okay, example 2, find the volume that is generated by revolving the portion of the curve y equal to x minus x squared between x is 0 to 1 about the x-axis. So let's sketch first. We have the parabola y equal to x minus x squared. If I find the value here of my x, so I equate equal to 0. Factorize this, I should have 1 minus x equal to 0, which gives me x equal to 0 and x equal to 1. So here 0, here 1. So I should have this parabola here. Okay, then you can calculate the value here. You can calculate here. This is actually from the idea of critical point. You can recall back your chapter 3. Then you should get here y equal to 0.25. So this is our region. Okay, this is our region bounded or by defined by this upper bound, the curve here, and the lower bound by the x curve here, x-axis here. Then everything here is actually give us the radius. You can find the radius here from this point to the fx here. You can find also the radius here, okay, from this point to the fx here. So when we talk about radius, means that we will have some kind like a solid, okay. So we revolve about the x-axis. So revolve about the x-axis, you will have, okay, you can imagine if you revolve, you pushing this area here or this curve here about the x-axis, so you will have another portion here, okay, another portion here. So now we want to find the volume of this part, okay, we want to calculate the volume of this solid. Alright, how to calculate the volume? Then we will use this formula. Okay, so we have V equal to integrate from 0 to 1 pi fx squared, so x minus x squared dx. Alright, so I expand first. 0 to 1, pi. So x minus x squared square, I should have x squared minus 2 x cubed plus x power 4 dx. So pi is constant, I bring outside. Then I integrate everything here. Okay, integrate everything here, I should have x cubed over 3 minus 2x power 4 over 4, which is x power 4 over 2 plus x power 5 over 5. Then from 0 to 1. So pi, substitute your 1. 1 power anything is 1. So 1 over 3 minus 1 over 2 plus 1 over 5. And then minus, when all x is 0, so you have 0. If you use your calculator, you solve for this fraction here, you should get 1 over 30. So multiply with pi, you should get pi over 30 unit cube. So this is the total volume for this solid here. Alright. So if I can show you by using maple, again, this is what we sketch. This is our curve given by this fx here. And then this is the solid of revolution. Then we can calculate the volume. Okay, as what we did. So this is the total volume if I multiply with pi. Okay.